Today we're going to be talking about squares and square roots. Throughout the video, please follow along in the notes provided to you and take your own notes. Please also feel free to pause the video at any time or go back and rewatch a section that you may not have been sure of or just want to watch again. What are squares? So you might have heard of squares before by hearing the term exponents, taking something to the second power, squaring a number, all sorts of things like that. But in order to find the square of a number, you must multiply the number by itself. An example of that would be by taking 2 times 2. We know that equals 4. But 2 to the second power is also equal to 4. This means that when you're squaring a number, you're taking it to the second power or squaring it. The terms are used interchangeably. Take a look at the bottom right corner. When we rewrite this 2 to the second power, I just wanted to point out that the 2 that we're taking to the second power is our base. But the small 2 up top that's attached to that number is called the exponent, or the power that that number is being taken to. So you may hear those terms throughout these lessons. You can find the square of any number, but we call the squares of whole numbers perfect squares. Remember that the whole numbers are the numbers that start at 0 and go from 0, 1, 2, 3, etc. They do not include fractions, decimals, or negatives. Some examples that we could see of perfect squares would be 2 to the second power that we saw in the last slide, or you could see 3 squared, which equals 9, 12 squared, which would be 144, up to any whole number that you want to take it to. We're going to be focusing on the first 20 perfect squares. Here we have a list of the first 20 perfect squares. In order to fill this out, you need to remember that 1 squared is the same as 1 times 1. 2 squared would be the same as 2 times 2, and so on. Please take a moment to pause the video and fill in the perfect squares up to 20 as best you can from your memory. When you have filled in as many as you can, please resume the video and we will talk about the perfect squares. One squared will give us 1. 2 squared gives us 4. 3 squared will give us 9. 4 squared, 16. 5 squared, 25. 6 squared gives us 36. 7 squared will give us 49. 8 squared gives us 64. 9 squared gives us 81. 10 squared is 100. Please check your work. Hopefully those first 10 are some that you have seen in the past and came back to you quickly. The next 10 may be a little trickier. 11 squared is like 11 times 11, so we get 121. 12 squared is 12 times 12, 144. 13 squared will give us 169. 14 squared gives us 196. 15 squared will be 225. 16 squared will give us 256. 17 squared will give us 289. 18 squared will give us 324. And 19 squared is 361. 20 squared, nice and easy, is 400. Please take a moment to fill these in on your own sheet. As we continue to do problems with these perfect squares, they'll come more naturally to you, especially those ones that are higher numbers, but it will be a good idea to keep looking over this list and make yourself very familiar with it, because it will be something that we need to be tested on in the coming weeks. So we've talked about squares and squaring a number, but to do the opposite of squaring a number, we find the square root. So remember that a root, when we're talking about multiplication, is one of the numbers that we multiply together to get an answer in a multiplication problem. So when we're talking about the square root of a number, you can think of it as one of its two equal roots. So you're looking for the roots of that number that are multiplied together, but they must be equal, and that makes it a square root. You can remember this because the sides of a square are always equal. So if you have a square with one side length of 4, that other side length must also be 4. Therefore, to find the square root, you must find which number times itself is equal to the number under the radical. That little check mark looking sign is called the radical. The radical is used to denote that you need to find the square root of a number. The directions of this section tell us to find each square root. Looking at example 1 together, it says that we need to find the square root of 16. 16 is equal to 4 times 4, so I'm going to rewrite this as the radical 4 times 4. All I did was rewrite 16 as 4 times 4. But since we have two roots that are equal to itself, that means that the square root of 16 is just 4, and we can say that the square root of 16 is 4. So in number 2, think about what's equal to 100. What number multiplied by itself gives us 100? It's going to be 10 times 10, and therefore the square root of 100 is equal to 10. Go ahead and try the remaining problems on your own. Pause the video when you have completed through number 12. Unpause the video and we will go over the answers together. So in problem number 3, the square root of 144, 12 times 12 gives us 144, so that means that the square root of 144 is 12. Square root of 25 will be 5. The square root of 9 is 3. Square root of 49 is 7. The square root of 121 is 11. The square root of 100, oh look, they gave it to us a second time. It's 10. Hopefully you were paying attention there. Square root of 81, 9. The square root of 256 might be a newer one for you, 16. Square root of 4, 2, and the square root of 36 should give you 6. Please go ahead and make any corrections you need to on your paper before moving on. The directions of this next set of problems tells us just to find the square. In our last problems, it said to find the square root, and we saw the radical sign over each of those numbers. But now we're finding the square. So in number 13 we have 9. And we're squaring that, so we take it to the second power. But taking something to the second power is just like 9 times 9. And if you recall, 9 squared is 81. Please take a minute to fill in 14 through 16 on this sheet. Number 14, you should have gotten 10 squared equals 100. In number 15, squaring 17 is going to give us 289. And in number 16, 6 squared is 36. Please make any corrections to your notes in case you made a mistake. This next section is asking us to circle the square roots of perfect squares and then evaluate. So the first step we need to do is find which one of these are perfect squares, and a reminder that perfect squares are the squares of whole numbers. So you're looking for the squares of whole numbers, and these should start looking familiar to you from this list that we have been seeing in the past few slides. So go ahead, take a minute to pause the video, circle on your sheet which one of these are perfect squares. Alright, so you should have circled the square root of 64, the square root of 324, the square root of 196, the square root of 121, and the square root of 361. Now, the second step of our directions tell us that we need to evaluate these. So the square root of 64 will be 8. Go ahead and take a minute to evaluate the rest of the perfect squares on this list. Alright, the square root of 324 should be 18. The square root of 196 will give us 14. The square root of 121 is 11. And finally, the square root of 361 is 19. Go ahead and check your work and make any corrections that you need to. Moving on to the next section. It asks, are these perfect squares? If not, which perfect squares do they lie between? Take a minute and decide if any of these are perfect squares. Looking at example 1, the square root of 101 is not one of our perfect squares, so I'm just going to go ahead and say no to that one. The square root of 32 in number 2 is also not one of our perfect squares. However, in number 3, the square root of 121 is a perfect square. So that one is perfect, and that is for 11. So the square root of 121 is equal to 11. Now, it said if they're not, what perfect squares do they lie between? So for the square root of 101, you want to look at that 101 and think about which perfect squares are between that, or are surround 101. So thinking of that, the closest one to 101 is actually 100. That's the perfect square of 10 squared. And then the one that comes after that would have to be 11 squared, which we know is 121. So that means that if we didn't have a calculator and we wanted to estimate the value of the square root of 101, we could find the two perfect squares that surround it, and then 101 is a lot closer to 100 than it is to 121, so I would maybe estimate this using this approximation symbol as about 10.1. So this is just a good method for approximation, as well as seeing where these numbers are compared to our perfect squares. Now in number 2, we have the square root of 32. So think about which numbers surround 32 from our perfect squares list. The numbers that surround it from our perfect squares list are going to be 25, which is 5 squared. And then the next one above that would be 6 squared, which is 36. Now 32 is kind of close to being in the middle of these two, might be a little bit closer to 36 here. So if we were going to estimate this here, maybe we could say, we could probably say about 5.6 maybe if we were going to estimate this. So once again, these are just good tools for estimating maybe what a square root is if it's not one of our perfect squares. This section asks which perfect squares lie between the two perfect squares. So kind of opposite of what we just did. So we have 100 and 144. So take a minute to figure out which two perfect squares are 100 and 144. So you should have come up with 10 squared and 12 squared. So that means that the perfect square that lies between them would be 11 squared, and that is 121. Please pause the video and try 5 and 6 on your own. So in number 5, we see that we have 36 and 64. This perfect square for 36 is 6 squared, and 64 is 8 squared. That means that we went from 6 to 8. That number in between is going to be 7, and we'll square that. So 7 squared is going to give us 49. Now in number 6, we have 49 and 81. We just said 7 squared is 49, so that one was an easy transition. And then 81 we know is 9 squared. Now the numbers between 7 and 9, that's 8, the whole number in between them, and that squared will give us 64. So there are the perfect squares that lie between the two perfect squares listed for each of these. Please make sure that you have these correct in your notes and make any corrections you need to before moving on. In our last unit of integers, we talked a lot about models for showing the operations that we were using in class. So now there are models that we can use to represent these square roots. So which model represents the expression the square root of 400? Now remember, square root of 400 is 20. So if we're talking about a square root of 400, and the answer there is 20, remember that the definition of square root is that we have two roots that are equal. So 20 times 20 is going to give us 400. If we're talking about square roots, we should probably be looking for some sort of square that is 20 by 20. So which one of these options do you think best represents 20 by 20 or the square root of 400? Take a minute to find your answer. The correct answer here would be A. Both of these sides are 20 units long, which means that in this model right here, there are 400 little squares. Seems like a lot, but they're there. Now, B was incorrect because we had 25 by 16. C was only 20 by 2. And D was 40 by 10. So they may all multiply. This one down here multiplies out to 400, so there might be 400 squares there. However, as a whole, we want to find that square because we want the roots or the sides of the square to be the same. So we need that square there, not a rectangle. So when you're asked to look for one of these models, try to find the square that is the correct number. Now based on what we just saw, this direction says create a model for the square of 4. So you just saw a model that was already created for the square root of 400, but now we're trying to do the square of 4. Remember that the square of 4 would be 4 squared. So take a minute to think about what that would mean for a model and go ahead and sketch one out on your notes. Please pause the video. So your model should look something like this, where you have 4 blocks on one side, 4 blocks on another, and we know that the 4 squared is 16. So the total number of blocks then that you've drawn should be 16. 4 by 4, or 4 times 4, 4 squared is 16. And this is a good model to represent that. Please check your work. Alright, thanks for paying attention to the lesson and following along in your notes and working hard. What I need you to do next is go to this hyperlink for http://bit.ly/2y1l5f9. Please be sure to type this in case sensitively, so capitalize that L there. This is going to take you to a quick Google form for a formative that I would like you to complete before you leave class today. I'm going to be taking a look at these to see how this video went, what we learned, and what we still need to work on when I get back. Please follow the directions on the Google Doc for the remainder of your class period once you've completed the formative. Thanks for listening. Have a great day.